This is the video notes that are going to go with solving standard form systems of equations by substitution. So we're building on what we did in our last lesson, okay? In this set of notes, our equations are not all going to be in slope-intercept form. So we're going to look at what steps we need to add to the process at the very beginning to help us out, okay? So if I look at example 1, okay, if I look at example 1, I have right here still in slope-intercept form, y equals 2 minus 6x. So what I know is that y is truly equal to all of that, okay? But if I look at my second equation, the 9x plus 2y equals 3, that's not in slope-intercept form, okay? But I can still do my substitution, because what I'm going to do is I'm going to take this whole little box right here, the 2 minus 6x, that I know that y is equal to, and I'm going to take it and I'm going to put it in place of y in my second equation. Now let me show you what I'm talking about. I'm going to start with the 9x plus 2y equals 3, okay? I'm going to take this y right here. I'm going to pick it up. I'm going to pluck it out. I'm going to throw it away over to the side. But in its place, I'm going to pick up this box right here and put it in that spot. I'm going to substitute it. Okay, now what is that going to look like? Watch what I'm doing. 9x plus 2 times y. But I know right here where my thumb is bopping up and down that y is 2 minus 6x. Notice I made it look like the distributive property because everything that's part of the y over here has to be multiplied by the 2 that's in that equation, okay? And we know that's going to be equal to 3. Now, what happened here by replacing this y with all of this right here is, if you notice, I don't have 2 different variables. My variables are the same letter, so I can actually solve it and come up with a number amount for my answer, okay? So that's what I'm going to do. I'm going to solve this right here for x. So I've got 9x plus, do your distributive property right here, 2 minus 12x equal to 3. Combining my like terms, negative 3x plus 2 equal to 3. Now, subtract the 2 from both sides. I've got negative 3x equal to 1. Divide by the negative 3, x is equal to 1/3, and that is negative. So, I now have an answer for x, okay? Well, it's just like we did yesterday. We figured out what x was. Now I've got to figure out what y is. So what I'm going to do is I'm going to return back to this first one, because remember, I'm trying to find y, and this one says y equals. Okay, so now what I'm going to do in the second half of the process is replace the x with the negative 1/3. So I'm going to have y equal to 2 minus 6 times negative 1/3. Well, then that's y equal to 2. Now look right here, a negative times a negative is going to make that a positive, and 1/3 of 6 is 2. So y is really 2 plus 2, which is 4. I'm going to write that as an ordered pair. And I am done. Okay, well, that's supposed to be a 3 and it's smudged. More like a 3. Okay, now pause your video, copy this down, and go to example 2. Okay. Now, example 2 is going to add just a little bit more difficulty to it because none of them is in slope-intercept form. Okay. What I do notice right here, and I even kind of capitalized it for you. See how this second one has just that little plain x, 1x. I want to use that 1x, okay? So the first thing I'm actually going to do is solve that equation for x. So what does that mean for me? I'm going to do x plus 8y equal to 26. Now, if I want to solve for x, that means I have to subtract the 8y and put it on the side with the 26. So what I'm going to have is 26 minus 8y. Okay? Now, watch this carefully. Get another color right here. I took my second equation and I solved it for x because that was the one that had the 1x. I'm going to take this right here that I know that x is equal to. I'm going to go to the other equation. Okay, I'm going to the other equation and I'm going to replace the x in that equation with all of this. Okay, so how is that going to look for me as far as work? So over here, I'm going to grab this first equation because I haven't done anything with it. You can't use the same equation for both of these parts. You have to use the other one. Okay, I've said that 3 times. That's important. Okay, and I'm going to have plus 2y equal to 16. Okay, now I'm going to replace x with all of this. So what I'm going to have is 5 times 26 minus 8y plus 2y equal to 16. So now we're just going to solve this. So we're going to have 5 times 26, which is 130, minus 40y plus 2y equal to 16. Combining my like terms, 130. Now negative 40 plus 2 is negative 38y equal to 16. If I add or subtract the 130 from both sides, it's negative 38y equal to negative 114. When I divide, I get y equal to 3. Okay. So I now know my y coordinate is 3. Now I'm going to go back and I need to find my x. I'm going to go right here and I'm going to grab this right here for the last part of the problem because I'm looking for x. So I'm going to use x equals 26 minus 8y. A little divide there so you can separate it for you. And that's going to give me x equals 26 minus 8 times 3. Well, that's 26 minus 24. So that's 2. Now I'm going to make sure when I write my ordered pair that I put the x and the y in the correct spot. So my final answer is 2/3. Okay, so go ahead and finish copying this down. Pause it if you need to, and then we'll go to example 3. Now, same thing here. Example 3, I have x plus 6y equals 7, negative x minus 2y equals negative 2. I am going to look for the variable that has the 1 coefficient. In this case, it is my first one. So I'm going to grab this first equation right here. X plus 6y equals 7. Solve it for x. We know that means I subtract the 6y from both sides. So 7 minus 6y. Okay. Now, in the next part, I'm actually going to use the second equation. So, and I'm going to put a 1 placeholder right here. So negative 1x minus 2y equal to negative 2. The reason I put the negative 1 placeholder is because when I substitute all of this right here in place of that x, I'm going to have to multiply distributive property type by negative 1, okay? So what I'm going to have is negative 1 times 7 minus 6y minus 2y equal to negative 2. That's going to give me negative 7 plus 6y minus 2y equal to negative 2. When I do my distributive property, now combine the like terms. Negative 7 plus 4y equal to negative 2. I add the 7 to both sides. So 4y is equal to 5. And that means y is equal to 5/4. Okay. Now I'm going to leave that just as a mixed number. I'm in improper fraction. I will not turn it into a mixed number. I could make it a decimal if I wanted to, but I'm not going to. Now, I need to figure out what x is, okay? So what I'm going to do is come back right here, and I'm going to grab my x equation, which is x equals 7 minus 6y. That means I'm going to have x equal to 7 minus 6 times 5/4. X equals 7 minus, all right, now look right here. Let's be really careful. We can do this. 6 and 4, that simplifies. 6 would be in the numerator, 4 in the denominator. They're both multiples of 2. So I could divide them both by 2 and I would get 3 and 2. So what I've got is 3 times 5, which is 15 over 2. Okay. Now, if I don't have a calculator, this is easy to do. What fraction is 7 if you have a denominator of 2? Well, that would be 14 over 2 minus 15 over 2. So that means x is equal to negative 1/2. Okay, so that means in my final answer, my ordered pair is going to be negative 1/2 and 5/4. Now, y'all, I didn't slow down up in here about the fraction. If you're having problems with abstract multiplier dividing fractions, then you need to, on your own time, go back into Google and Google some sites that will help you with tutorial with that. Okay, go ahead and copy down example 3 and make sure these notes get put into your interactive notebook, and then you can work on your assignment in Canvas.